So, lecture number 9, some application of the quantum mechanics. Quantum computing certain computational capabilities that cannot be even imagined by conservational methods may be possible in the so far ever future. For illustration, quantum algorithm would need applied and the unkit of quantum leap as for factoring and conserving as illustrations say one of the ones factors are very large integer. What the existing fastest supercomputers is estimated to take time to the order or the age of the universe. But it would only matter a few seconds of a maximum and a few minutes for quantum computers around second of the maximum few minutes. The short simulates the growth new efficient quantum search, and the mean searching could be speeded up millionfold for very large value of n. And what is impossible present day might quite possible in future due to development is a field of quantum computing and the computational algorithms. The technical difficulty of producing in quantum computers is a problem of which a big Hebrew is it's a primitive of quantum computers where development with limited functions. They have a lot of experimental values, and the next is the quantum cryptography. The throw of cryptography is really new, only 1970 in the search in cryptography, cryptanalysis, and related analysis gained observable inputs in the cryptography has previous application of information communication, and we have the cryptography included. A is cryptography, the art of encrypting sending a message, and the B is the cryptanalysis, the art of disguising. In order to do this is algorithm cryptography is jumping as a message with that knows the key to produce cryptography, and therefore it's the analog to the cryptography without the today's days. Next is the page number 9. It is a formulation. So, lecture number 9, approximate methods of quantum mechanics. So, in the section of the word ordinary application will be presently very simple method. It has already been inducted without justification in section, and it's certainly the most important and most section for approximation in quantum mechanics is a stationary state of limited molecule can be described in quantum mechanics by wave functions psi and the h. This, according to the Schrödinger equation in this formula, we see the h psi equal to the psi, where h is the Hamiltonian equation. Hamiltonian of the equation, and it depends of electric, nuclear, and spin coordinates. That the Hamiltonian factor a large number of independent variables that must be separated, and the obtained equation that can be solved with the values of the H types. The next formula. Next formula, the Hamiltonian for a system composed of the number in nuclei and electrons can be written in the form in this formula, which is the H equal to the sum of the H squared divided 2mg and the square minus sum of the H squared 2mi squared plus VGG and the VII and the VIG. And where where we Vg equal to the 1 divided 4p E0 equal to the sum of the Zg square divided Rg. And V equal to the 1 divided 4p E0 sum of the E square divided Li. And the first two terms is represented by the kinetic energy nuclei and the electrons. Presently, the remaining the term specify the potential energy as a function of the interaction between of the particles. Equation express the potential function for the integration each prime nuclei. The next formula we see the useful. It's a useful the present context. For the context to separate the Hamiltonian equation into two parts as given by psi electron divided psi and the sum of the h square psi nucleus plus psi h square 2 divided 2mi plus vi vig and the psi. And as the first term, and at the first term, the quantity of the square brackets can be really invented as H electrons and psi electrons equal to the E electrons and psi electrons, where E equal to the E electrons plus A nucleus. With the height of the summation and the multiplication of this expression, we see the next formula. Sum of the H square divided 2mg plus psi nucleus plus Vg psi nucleus plus E electrons means A is equal to the this obtained. And the argument of present raising paragraphs of Kirchhoff's is to the understand the reference with geometric molecule, and it should be experiments on the born accurate explanation of an externally good one.